Hello everyone, this is Shubh and welcome to My Skills, My Future, a career mentoring platform. Hope you guys are prepared well and I'm going to teach at second grade. I will be teaching from basic level to advanced level and also we will provide you the material and topic wise examination and it is also useful for both preliminary and mains level of examinations. We are going to cover each and every topic from basic level to the advanced level. It is useful for every exams such as banking, SSC, railway and state government examination. Today we will be discussing the topic of mixtures. From the topic of mixtures, we get questions frequently in all the competitive examinations. Whether you write bank exam or SSC exam or exam, you will get questions from the exam in all the can expect one question from this topic. And one more important thing, before closing the topic, I recommend you to watch the topic of ratios and after completion of this ratios and proportionality, then you have to watch this topic mission. Reason is application of ratios and proportions will be used in the concept of this mixture and alligation. And this mixture and alligation. So it is an application of ratios and proportions. So try to watch the first ratios and proportions topic and then watch mixtures topic and don't forget this is very easy and simple topic. Yes, you can solve issues based upon mixture very easily in examination just in a fraction of. So what will I do is first I'll explain after the completion and then we'll solve questions based upon a simple manner. Definitely, you can expect one question in this topic. Okay, we'll first discuss the concept. So here you have okay. Okay, let us go with the lesson outline of our today's session. So regarding introduction part of mixtures. So this mixture and allegation is divided into two parts. So mixtures we will discuss separately and allegation will and after the introduction part completion and we'll try to cover some basic example problems and after that we try to cover the various model which will cover various model which will be under the topic of this topic and after the completion of the topic we'll go to the allegation topic and for understanding that the allegations topic try to cover some basic exam and after completion of those things we'll try to cover the some example problems here. So this was a lesson of accordingly we discuss one by one in our next lectures and the next sessions here. Okay, let us move to the introduction part of mixtures. So here the point is what is meant by mixtures? What is meant by mixtures and how the quantities can be mixed and what can be mixed in the mixtures. So before going to the detail in the let us try to find the definition for mixtures first. What is meant by mixture? Mixture means mixture. I am telling the definition directly. Mixture means mixing two or two or more quantities, two or more quantities in a defined ratio. Defined ratio. So, so how to mix here? Suppose I have. So let us consider an example. So I am taking a container or a vessel contains milk here. So this milk is of let us assume 40 liters. And what I'm doing, I'm mixing that milk with some water in it. So for purchasing means I need to spend some rupees here, but water will be free of cost. So let us assume I have mixed 10 liters of water in it. Liters of water here. Okay. This container or vessel A contains pure milk that is of 20 liters and vessel B contains water that is of 10 liters. Now what I am doing here is I am mixing these quantities of these vessel A and vessel B. Now what I will get the resultant here? I will get the resultant of milk and water. So that too of 50 liters here. Of 50 liters. Suppose if I ask you in what ratio that the milk and water contain means, you can see here the milk quantity is of 40 liters and the water quantity is of 10 liters. So if I take the milk to water ratio, milk liters and water is of 50, and the ratio will be of 4 is to 1. So in this 50 liters, the milk to water ratio will be of 1. Milk to water ratio will be 4 is to 1. So what I am trying to explain here is, here I am taken pure milk of 40 liters, I am taken water here, and after, okay, I have mixed both water and milk here, and when we mix milk and water, when we mix two quantities, two independent or two different quantities, and when we combine them or mixing them, that mixture or that quantity we call it as a mixture. So the definition of mixture is mixing two or more quantities. Here I am mixing two quantities. What are the two quantities? Here I am mixing milk here, and here I am mixing water, and I am getting some new mixture that contains new vessel or new quantity that contains both milk and water. Next, so this is about definition of mixture. So what is the definition for mixture? Means mixing two or more quantities in a defined ratio. Two or more quantities in a defined ratio. Next, how to mix the quantities here? To mix the quantities here. So there are different ways to mix the quantities here. So here I am just whatever the contents which are present in this and one this milk container A and container B are visual A and visual have totally transferred into a new container here. Have totally transferred into a new container. But suppose let us consider one more example here. Let us assume a container or vessel A contains milk and water in a ratio of 1:2. Let us assume another container B and it also contains milk and water in the ratio of 2:3. Now, now this A and B are both are mixtures here. Both are mixed. Why? Because it the vessel A contains milk and water and vessel B also contains milk and water. Now what I am trying to do is I need to mix these two quantities or these two mixtures into a new quantity or new vessel C here. So this one also contains milk and water here. Now the thing is here is we need to find what is the ratio of milk and water in the new container or new vessel. But the point here is in what ratio we need to mix these quantities here in order to get it. So we may mix it in equal ratio here. There are 2 points here. We may mix it in equal ratio. We may mix it in defined ratios, or we mix it in defined ratio or given ratios. Given ratios. Given ratio equal ratios 1:1 ratio, and defined ratio given ratio it may be like 1:2, 2:3, 4:5, or any of the given ratios. So what it actually means, suppose if equal ratios means 1:1 ratio. What it means actually means we need to take one part from container one and one part from container one. After taking one part and one part from container one, we take a container. But it means in a defined ratio or given ratio. Suppose if the ratio was a 2:3, we need to take two parts from container one and three parts from container three. Before taking the two parts and three parts, we need to make something before that one. So I'll tell you in the next slide here. Next, what can be mixed in the mixtures? So in the mixtures, we can mix either solids, liquids, or gases. Solids and liquids, or liquids and gases, or solids and so any of these combination we can mix here. So we may mix solids with we may mix here solids with solids here and solids with liquids here, solids with gases here, or we may liquids with gases here, liquids with solids here, or liquids with liquids also we can mix it. So any of these combination we can mix here. So this is about today's main by mixture and how to mix the quantities here and what can be mixed in mixtures. I hope we are clear with this explanation. And let us take an example here in order to understand the concept here. So here I am considering a vessel. Vessel A contains milk and water. Vessel A contains milk and water in the ratio of 6:7, and vessel B contains milk and water in the ratio of 8:5. Milk and water in the ratio of 8:5 or 8:5. What I am trying to do is I need to mix it into I need to mix it in a very big container C or big vessel C. In what ratio I need to mix? In 1:1 ratio, I am mixing these containers. But it means I am taking one part from container 1 and taking one part from container B here. After taking one part and one part from each containers, we need to get some ratio of milk here. That ratio we need to find here. So first I'll tell you the general traditional method how to solve this method or how to solve this type of question. After completion of this traditional method, I try to explain the shortcut method. With, with a shortcut method, we will be able to solve the question in less time. So how to approach in exam oriented also we'll try to cover it. So let us take here. Here I am taking milk quantity here and here I am taking water quantity. So what is the milk quantity present in container 1? So there is milk quantity is 6 parts in container 1 or visual way. So out of how many parts if I add these milk and water in container 1 it will be of 13 parts. So there is 6 parts out of 13 parts. There are 6 parts of milk out of a total of 13 parts here. So this is regarding container A. Next, similarly, in the container B also, there are 8 parts of milk out of how many? So 8 plus 5 is also 13. So there are 8 parts out of 8 parts of milk out of 13 parts of milk. Now, how many parts we need to take here from this one? We need to take from one part here. Next, similarly, also there are 7 parts of water out of 13 parts of, and there are 5 parts of water out of 13 parts, and we need to take it one ratio. Next, if I simplify this equation, it will be like will be converted like 14 divided by 13 ratio 12 divided by 13. So 13 and 13 get cancelled here, and this can be cancelled with 7 2s and 2 6 get cancelled here. So what is the ratio I'm getting here? I get the ratio of 7 is to 6. So when if vessel A contains milk and water in the ratio of 6 is to 7, and vessel B contains in the ratio of 8 is to 7. If I mix it in 1 is to ratio, 1 is to 1 ratio. Then the bigger vessel contains milk and water in the ratio of 7 is to 6 here. 7 is to 6. But if you try, but if you go this method, any of these are the simple equations, you will be able to solve this one. But sometimes this method is difficult or time taking money. Difficult or time taking money. So we need to go for some simple method here. We need to look on for some simple method here. So let us say that the simple method here. Let us say that the simple method here. So I'll try to explain this simple method here. Okay, let's see the explanation here. So here now I am trying to solve it in a shortcut method. Now I am trying to solve it in a shortcut method here. So here I am taking milk and water. So what is the milk and water contained in container one? Or so it is a 6:1 ratio. How many parts it is? It is a 13 parts here. And what is the milk and water ratio in container two? It is 8:5. It is also how many parts here? It is also 13 parts. Now the thing is when we are approaching and when we are doing problems by using shortcut method, one point you need to remember. What is that point means? You need to make the number of parts to be same. You need to make number of parts to be same, number of parts to be same in both the containers or both the mixtures or both the vessels. So what you need to do, you need to make the number of parts to be same in both the containers here or both the mixtures here or both the vessels here. So here if I see here, the number of parts present in container A is also 13 parts, number of parts present in container B also 13 parts. And now what is told in the number of parts system, there is no nothing to do with that with. Next, in what ratio we need to mix that one? So we need to take one part from container one and we need to take one part from container two. So multiplying one with will give us the same result. So if I do this one, it will take 6 is 7 and 8 is to 5. Now what I am doing, I need to add those two. Observe here, it is also 13 parts and it is also 13 parts. When the number of parts are same, adding those quantities into a big vessel is easy for us. So in order to add the contents of smaller vessels into bigger vessels, what you need to do is you need to make the number of parts to be same before mixing the contents in a defined ratio or equal ratio. So here first I will make the number of parts to be same. After making the number of parts to same, and I am mixing it in a defined ratio here. Defined ratio, that is 1:1 ratio. After making 1:1 ratio, now I am adding these contents in. So it will be like 14 and 12, and if I simplify this equation, it will be like 6 is to 6. So the quantity of milk and water present in the new container or big vessel will be in the ratio of 7 is to 6. I hope we are clear with this explanation. We are doing one more example problem here, and we are going to one more example problem here. So this is the another example problem. So for this particular problem, I'll explain directly with the shortcut method here. So milk and water. So the milk and water is the so it is how many parts? It is 9 parts here. And milk and water in the second container is of 7 is to 11. So it is of how many parts? It is 18 parts. But I have told before mixing the quantities, you need to make the number of parts to be same in both the containers. But if I observe here, the number of parts present in the container A is of the number of parts present in container B is of 18 parts. So for that, what I try to do, so we need to make or we need to multiply the first container with 2 here. So after multiplying this one, so here also I need to multiply this one with 2. Here I have nothing to do. Why? Because if I do this one, it is also 18 parts and it is also 18 parts. Both the number of parts are same. When both the number of parts are same, now mixing is easy for us here. So in what ratio he asks us to mix? So he asks us to mix it in 1:1 ratio. We need to take one part from container 1 and one part from container 2 here. After multiplying the values here, it will be like 14 and 4 like this 7 and 11. We observe here also 18 parts and here also 18 parts are present. Number of parts are same. When mixing it in equal ratio, we will get the same number of parts here. Now, what we need to add the things here, or we need to add these container 1 and add container 2 values to be big vessel here, big vessel here, and we and what is the milk and water present in the bigger vessel here. So if I add this one, it will be like 21 and 15. And if I eliminate the common number present here, it will be like 7 is to 5. So the quantity of okay, the ratio of milk and water present in the bigger vessel will be in the ratio of 7 is to 5. 7 is to 5. I hope we are clear with this explanation, and we are moving to the next one here. Okay, this was the next one here. These are the similar kind. But only the difference is in the previous two example problems we covered only in equal ratio. Now we are mixing it in 4 is to 3 ratio here. We are mixing it in 4 is to 3 ratio. So this container 1 contains milk and water in the ratio of 3 is to 4 and container B contains milk and water in the ratio of 5 is to 2. And what we are trying to do, we are mixing them into bigger vessel and we need to find what is the ratio of milk and water present in the bigger vessel here. So let us take here milk and water. So it is of 3 is to 4 and it is of 5 is to 2 here. And here it is a number of parts will be 7 and the number of parts will be also 7 here. If we add the things here, it will be like 8, 10, not this one. And we need to, here the number of parts are same here. When the number of parts are same, we are now we don't need to do nothing here. And what we add for the access to it, we need to take 4 parts from container 1 and 3 parts from container 2 here. After doing here, like 12 and 16, it will be like 15 and 10. Now we need to add these two here. It will be like 27 and 26. So the ratio of milk and water present in the new ratio of milk and water here will be 6 here and it will be like 22 here. So 27 ratio 22. 27 ratio 22 here. So the ratio of milk and water present in the new bigger vessel will be the ratio of 27 ratio 22. 27 ratio 22. Let us consider also one more example problem. Okay. So this was another example problem. So I give here milk and water in the ratio of 2 to 4 and the number of parts here will be 6. And the milk and water ratio is 5 and 5 ratio 9. The number of parts will be 15 here. And what I told we need to make the number of parts to be same before mixing the combined ratio or equal ratio. So for that I am dividing this one with 2 here. And if I do what he asks us to ratio is asked us to mix in 2 is to 3 ratio. What it means, we need to take two parts from container, parts from container. After multiplying the values here, 4 into 3 will be of 12 and 6. And 3 5 is of 15 and 9 is of 27. And if I add the values here, it will be like 7 and plus 7 will be 30 and it will be like 43. So it will become what 27 ratio 43. The ratio of milk and water present in the bigger vessel will be in the ratio of 27 ratio 43. I hope you are clear with this explanation. Till now, we discussed about what is meant by mixture, how to mix the quantities, and what are the various ways to mix the quantities. And after mixing that, we are discussing some basic examples to understand the how to solve the problems in a traditional manner and how to solve in an exam-oriented manner, the shortcut method. So these are all the points we discussed up to now. Next, by the end of listening, what you will expect here is you will be able to two or more quantities in a defined ratio and you will be able to solve the problems which were asked in the examination and you will be able to create a complete the given data. So these are all the things we will be able to learn by the end of this session. By the end of this session. Okay, let us start working on some problems here. After so we have discussed about the introduction part clearly. If we understand the introduction part clearly, then solving problems based on this measures is very easy and you will be able to get the answer within less time or 10 to 15 seconds of time only and if you practice more number of questions. Okay, this was the first example problem. But here, A and B are the two alloys of gold and copper prepared by mixing metals in a ratio of 5 is to 3 and 5 is to 11. Okay, let us take gold and copper. So it is a alloy A. It is the ratio of 5 is to 3. And alloy B contains what? Gold and copper in the ratio of 5 is to 11. So what is the number of parts here? Here the number of parts will be 8 and here the number of parts will be 16. But I told before mixing them, what we need to do, we need to make the number of parts to be same. For that, in order to make the number of parts to same, I am mixing one with the, I am multiplying this one with the two. So I am also multiply this one with 2 here. Next, these are okay, equal quantities. So remember here, equal quantities are multiplying that one into 1 is to 1 ratio. We are taking that 1 is to 1 ratio. Melted to form a new alloy. So that a new alloy, third alloy is formed. And what is the ratio of gold to copper ratio in the third alloy? So we need to find the gold to copper ratio. Okay, 2 into 5 is of 10 and 2 into 3 is of 6 and it's like 5 and 11. We observe here, here is also 16 parts, here is also 16 parts. And the number of parts are maintained same when we mix the quantities in equal ratio. So 10 plus 5 will be 15 and 6 plus 11 will be 17. So the ratio of gold and copper present in the new alloy C is the ratio of 15 ratio 7, so which is presented in option C here. So this is a very basic problem and easy problem. All you need to understand the concept clearly, then solving the problems is easy for you. Okay, let us go for the next problem here. Okay, what is the question is there are two bottles contains acid and water in the ratio of 1 is to 2. So what against acid ratio water 2 is to 3 in container, okay, bottle A and 1 is to 2 in bottle B. So the number of parts present in bottle A will be 5 and the number of parts here will be 3. What I told, we need to make the number of parts to be same before mixing equal ratio and definition. So for that, I am trying to multiply with 3 here, so I multiply with 5 here. So in order to make the number of parts to be same here. Next, in what ratio he asks us to mix? These are mixed in the ratio of 1 is to 3 ratio. So what it means, take one part from part A and we need to take the 3 parts from container B or part B. After mixing the quantities, get 3 into 2 will be of 6 and 3 into 3 will be of 5 and 15 into 1 will be 15. This will be up to 30. So if I add the things here, it will be like a 21 ratio 39. Now I need to check whether is there any common multiple present or not. So here the common multiple present is 3 multiple was present. 3 sevens and 3 ones and 3 is getting. So the ratio we are getting is the 7 ratio 13. So the ratio of acid and water present in the will be in the ratio of 7 ratio 13, which is 8. I hope you are understanding these problems and We are moving to the next problem. Here is the next similar kind of problem here. So what A content means alloy A contains copper and zinc in the ratio of 5 is to 2, and alloy B contains copper and zinc in the ratio of 1 is to 3. So if the number of parts here will be 7 and here the number of parts will be 4. In order to make the number of parts to be 7, this one I multiply with 4 and this I multiply with 7 here. This I multiply with 4 here and this I multiply with 7. And here we are taken in the ratio of 9 is to 8. So 9 parts are taken from container A and 8 parts are and are melted from a new alloy. And what he asked in the question is, first we try to form a new alloy here. So 4, okay, 4 ones and 4 twos get cancelled here. Okay, 9 into 5 will be 45 and 9 twos will be of 80. So this will be 7. 7 twos will be 14, 14 and 7 threes will be of 40. And if I add the things here, it will be like 59 and 60. So this is of copper and zinc. So the ratio of copper and zinc will be in the ratio what of 59 ratio 60. But this is not asking our question. What he asking the question is percentage of zinc. So how many parts are present in there are 60 parts are present in zinc. Out of how many parts? Out of 119 parts into percentage. So suppose in order to simplify this one, what I will try to do is 119 I will take that as 120. So 60 ones and 62 cancel. 1 by 2 is nothing but 50%. So my answer is very near 50%. Now I'll check which among the option will be nearer to 50%. So I'll confirm that only one option 50.40 is very rare to my answer. So I can get the answer. Or the percentage of zinc closest will be is 50.42 percentage. So these are the some example problems we covered in this section here. And we come to the conclusion part. Mixtures means two or more quantities in a defined ratio here. That means mixing around two defined ratio here. And this allegation part will cover in the next session or next sessions here. So now our main focus is only on the mixtures. After completion of this mixture, try to cover this allegation part here. And okay, let us take this assignment problems and try to answer in the comments. And I'll try to explain these problems in the next session. Thank you for watching this. Have a good day. We'll make one more interesting content on mixtures and allegations topic. Have a good day. We'll meet in the next session.